Okay, quadratic modeling. We are going to do the review for Unit 7. You've been given a chance to join the Woodward basketball team. The coach only asks that you can answer 2 questions to join the team. Those questions are, assume the path of a ball in a jump shot is modeled by this equation. All the coach needs to know is that you can figure out the maximum height of the ball as it reaches on the way to the basket and how long it takes the shot to enter. So I could probably qualify the basketball team if these were the qualifications. So let's draw what's happening here. So you've got something like this. So you've got someone who shoots a basket, and so obviously you put some arc on it, and it's going to go in the basket. Okay, so somewhere right here, shot goes in the basket. Okay, so what I'm being asked to find the maximum height that the ball reaches. So I'm asked to find the vertex. Okay, that's the first part of the problem. And then I'm told that the basketball rim is 10 feet. So I'm asked to find when is the ball at 10 feet. So those are 2 things. Part A, let's just find the vertex. So you know to find the vertex, the x-coordinate of the vertex is going to be negative 20 over 2 times negative 16, which is going to be 20 over 32, which is, I think 4 will go into there, so that's 5/8, which is 0.625. That's how much time it takes my ball to reach the apex or its maximum. They didn't ask me the time, they wanted the maximum height of my jump shot. So that's going to be negative 16 times 0.625 squared plus 20 times 0.625 plus 6. And this is a job for my calculator. So let's go ahead and do that. So that is going to be negative 16 times 0.625 squared plus 20 times 0.625 plus 6. So 12.25. So that tells me that 12.25 is the maximum height of my jump shot. Next question, how long does it take the basketball to reach, or the basketball shot to reach the basket? So that's basically a height of 10. Now look at my diagram. I'm probably going to get 2 answers. It's probably going to hit 10 feet on the way up because I'm less than 10 feet tall, and probably 10 feet on the way down. So I'm going to get 2 answers, and I know which one of those is the one they're after. Will be this, the largest of the numbers. So I just need to say negative 16 x squared plus 20x plus 6 equals 10, or negative 16 x squared plus 20x plus 6 minus 10 equals 0, negative 16 x squared plus 20x minus 4 equals 0. That's where I'm going to go with my TI Inspire. So menu, algebra, polynomial, complex roots, negative 16 x squared plus 20x minus 4 and comma x. So solve that, and I get 1/4 and 1. So interpret that. So that means 1/4 of a second into the shot, the ball is on the way up, that's where I hit, and then 1 on the way back is where it hits on the way down. So that tells me that x equal 1/4 and 1, but they've asked me for when it goes in the basket. So it's going to go in the basket after 1 second. That's when it goes in the basket. Okay? Let's take a look at our next problem. There's a typo in this. The data shows the number of mountain bike owners in millions in the US. The data is for 2010. Should be 2016, 2017. So T is the number of years after 2010. So T equals 0 is 2010, T equals 6 is 2016, T equals 7 is 2017. Come up with an equation that models this. So in order to do this, I need to input all of this data into the calculator and then come up with a model. So let's create that real quick. So I'm going to create a new document, and this is a list and spreadsheet. So I have years and I have bikes. So at year 0, I'm told that there are 3.962 million bikes. At year 6, I'm told that there are 2.504 million bikes. And at year 7, I'm told that there are 4.62 million bikes. And let's back up, 4.62. Double check. 0, 3.962, 6, 2.504, 7, 4.62. So the data is all there. I will now go and create a data statistics. My x-axis are the years. My y-axis are the bikes. And I'm going to fit a quadratic regression to there. Now it looks like it's chopped off. The axis doesn't actually go far enough down. I could resize that, but I really don't need to at this point. I can just take that model. So it's 0.337 minus 2.265, 3.962. So let's go ahead and do that real quick. So our model is y equal 0.337 x squared. So here's my model. 0.337 squared, so 0.337 t squared minus 2.265 t minus 2.265 t, and then plus 3.962 plus 3.962. In what year was the bike ownership at a minimum? So in order to find this, I just need to find negative b over 2a. So in this case, it's going to be negative 2, it's going to be the negative of negative 2.265 over 2 times 0.337. So if I figure this out on my calculator, so that will tell me that so 2.265 and 2 times 0.337. So if I go to a calculator page, so I'm going to have negative of 2.265. So negative of negative 2.265 is just going to be 2.265 divided by, and then I'm going to have 2 times 0.337. 2 times 0.337 equal 3.36. So if I get 3.36, so how many years is that from 2010? So 2010 plus 3.36, that's going to be 2013 is the year. If I look back at this, you know, there's a problem with this. There's obviously difficulty with this problem. Bike ownership doesn't go into the negative. So if you look at that parabola that we saw, the data is probably not well formed in this. At first I was thinking like, oh, maybe the axis is scaled and it doesn't go all the way up, but it looks like it's going to hit and go negative, which is not the case. So again, hopefully on a test I would have corrected that before you saw it, but just working through the data, this is what it is. You got the quadratic model. From the data I gave you, you can find the vertex, which is what I found here, and you see that in the formula. Let's continue on in this section. So let's look at another quadratic modeling. Six Flags is experimenting with a way to do, let me do that real quick. with a way to do acrophobia. Instead of slowly lifting to the top and dropping you, now they're going to start at the bottom and shoot you up in the air before you free fall back to the ground. So the ride will start with a platform of 5 meters, and it will launch you upwards at 29.4 meters per second. So sketch this problem. So what's going to happen is somewhere you are 5 meters above the ground. Let me make that a little bit clearer. You start out at 5 meters, and then you get shot up and you hit the ground. So it's something like that. And we've got the speed, everything like that. So let's come up with the equation then. So the equation is h of t is -1/2 gt squared plus initial velocity t plus initial height. So in this case, our equation is going to be h of t is equal to, because this is meters, that's going to be -1/2 times 9.8. So that's -4.9 t squared plus my initial velocity is 29.4 meters, and my initial height is 5. So that's the equation that everything is going to be modeled on. What is my height after 2 seconds? Well, t is equal to 2. So what happens when you plug a 2 into this equation? -4.9 times 2 squared plus 29.4 times 2 plus 5. So I'll just enter all of that in the calculator. So if I go to my calculator page, so that is going to be -4.9 times 2 squared plus, what was it, 29.6? Let me double check that. That was 29.4 and then plus 2. So 29.4 times 2 plus, and I got to double check that, plus 5. So plus 5. So 44.2. So that tells me when you substitute t equal 2, you get 44.2. That is going to be the 44.2 meters high after 2 seconds. Next question, how much time will pass before you hit the ground? You hit the ground when the height is 0. So all I have to do is set that equation equal to 0. So it's -4.9 t squared plus 29.4 t plus 5 equals 0. So I'll go back, and this is going to be menu, algebra, polynomial, complex roots, -4.9 t squared plus 29, trying to remember, is it 29.4? So 29.4 t plus 5 and comma t. Solve that for t. I get two numbers, -0.16 and 6.16. What makes sense in the context of this problem is the 6.16. So it tells me you're going to hit the ground after 6.1 seconds to hit the ground. This looks like another quadratic modeling. This looks like borders, or no, this is a fencing problem. Okay, so Chris Freer would like a wooden rectangular fence to keep the riffraff, mostly freshmen, juniors, and sophomores, freshmen, juniors, and seniors, off of his front lawn. The fence will be 3 sides, with the front of the house serving as one side of the enclosed area. If you only have 84 feet of fencing, what are the dimensions of the fence that provide the maximum area of seclusion? So Chris Fair lives in a house that has a front wall, and we are proposing to build a fence on 3 sides of that. Okay, so I have to define a variable. So let's just let x equal, right there, the width. So I'm going to let x equal the width of the fence in feet. Okay. Now, I know that I have 84 feet of fencing. So if I use x feet here and x feet here, then I know that the length of this fence has to be 84 minus 2x, okay? Because when I add x and 84 minus 2x, I get 84. So that has to be the way the perimeter of the fence looks, okay? And then what I want to do, I want to maximize the area. So the area, remember the area of a triangle is just length times width. So the area that I see there is x times 84 minus 2x. So that area is 84x minus 2x squared. I'm going to rewrite this as negative 2x squared plus 84x. I'm not sure where that stray line came from. Negative 2x squared plus 84x. That's a parabola that opens downward, okay? So even though I'm not doing a projectile or anything like that, I know that that equation is a parabola. If I want to maximize the area, the maximum for this function is going to occur at the vertex. So what's the maximum? I just need to find what the x-coordinate of the vertex is. So it's going to be negative b over 2a. So at negative 84 over 2 times negative 2, that's going to be 84 divided by 4, which is 21. So let's go back to the question. What are the dimensions of the fence? So I've just learned that this is 21, that's 21, and this is going to be 84 minus 42, which is 42. So this area is going to be 21 by 42. Those are the dimensions that will maximize the area for Chris Fear's fence. Let's continue on. We're looking at another problem here that's maximizing. This looks like I'm building some kind of border. So Woodward Academy wants to grow more of its own food for the cafeteria. Currently the lettuce garden is 60 by 40. We would like to plant a border of even width around the existing garden, and the school will end up making a garden twice the size of the existing garden. So I've got a garden here that is 40 by 60. So I know that is 2,400 square feet. Okay, so 40 by 60. I want to put a border around this garden. Okay, so a border and even width, and I want to end up with a garden that is double the size of the one that I have. So what I want to do, let's just first figure out x is equal to, I'll let x equal the width of the expansion. Okay, so if x is the width of the expansion, okay, so that means this is x, this is x, this is x, everything is x feet, x wide, okay? So it tells me that the new garden, so over here I've got 40, so this is going to be 40 plus 2x, and then down here the new garden is going to be 60 plus 2x. Those are the new dimensions of my garden, okay? So a model that's going to help me, I know that 40 plus 2x times 60 plus 2x, that's the area of my new garden, and it's going to be what? Twice the area of the original garden. So my original garden, so if my original is 2,400, then my expanded is going to be what? My expanded garden has to be 4,800. So this is 4,800. So if I expand this out, I'm going to have 2,400 plus 120x plus 80x plus 4x squared equal 4,800, or 4x squared plus 200x minus 2,400 equals 0. There's my model in standard form. So I just need to solve and find the width of that expansion. So to solve this, I just need to solve this for x. So 4x squared plus 200x minus 2,400 equals 0. I will go to my calculator gladly for this. Algebra, polynomial, complex roots. 4x squared plus 200x minus 2,400. Solve that, please, for x. Negative 60 and 10. So my expansion can be negative 60 feet, probably not good, or 10 feet. So x is 10 feet. Now 10, that is the width. So this is the width of the expansion. But my garden is going to be 40 plus 2x by 60 plus 2x. So that means my garden is going to be 40 plus 20, that's 60, and 60 plus 20, which is 80. So this garden is 60 by 80. One thing you can double check, what's 60 times 80? That's 4,800. Well, that's what the garden needs to be. It needs to be double what the previous garden was. And that should be it. That is the end of the book. So anyway, there's your review for the last unit that we have. Thanks.